My name is Paweł, and welcome to a presentation about Web API design. A few words about me for the beginning. So I'm a Java developer since roughly 9 years. Who of you is from the Java world, actually? Some people, okay, not everyone, but don't worry, the presentation will be basically technologically agnostic, so no Java at all. Don't run away yet. So as of me, I was working in telecom industry initially, then in logistics, then banking, then a Swedish car factory, and currently it's a travel industry via a software house, PGS Software. And the agenda will be looking more or less like an RPG party. Who is playing role-playing games? Yeah, there are some people good. So we have 4 characters in here. First, there will be Scout, where we will look at things from, let's say, distant perspective to get some overview. Then there will be Wizard, or actually 3 wizards on the Ivory Tower. So just a little bit of theory to get a good handle on the business part. Then the business part, so there is this dwarven warrior with an axe who is slashing orcs and goblins and doing the actual business job that we are getting paid for, hopefully. And behind this dwarf, there's usually the cleric, so the guy who is healing and buffing this dwarf, and that's a support. And in this part, we'll be talking about things that are kind of orthogonal to the business perspective, so not always very visible, but nevertheless very important. Okay, so the beginning. There was a guy in marketing by the name of Simon Sinek, and he wrote a book, Start With Why. And indeed, when we are starting any adventure, whether this is designing an API or throwing a ring into Mount Doom, it's good to have an idea why are we doing this in the first place. And then what are we actually doing and how to do that. So let's briefly look at those 3 questions. First question, why? That's kind of simple, for money. We do that for money. So how it worked in the past. We had our applications that had some kind of backend data, front-end, usually some users on the web who were clicking stuff, creating documents, maybe uploading pictures of cats to the internet so others could see. And we somehow earn on that either directly on or indirectly on advertisements or some other way. And as the time passes, we needed more functionality. So for example, if you were a hotel or some kind of travel business, we would like to display a map. And it's not exactly a good idea to create map oneself or drive with a car and do pictures of buildings. We have some other parties that already did that and do that quite well. And they have external APIs. So for instance, we can connect to Google API in that case. And as our system grows further, we have more data, more functionality that is kind of precious. So maybe it's a good idea to also create an external API so that we can earn on that, not only on single users on the front end, if that's our model. What is external API? Well, that's pretty simple. It's just a set of publicly available endpoints that have certain schema of request-response messages that we can communicate with. And how to do that? Well, that will be the objective of next 40 minutes, hopefully. But in general, there's an observation that API is to programmers more or less like graphical user interface is for regular users on the web. So there was quite a lot of things and knowledge set and created about how to design a good graphical user interface. So we can leverage some of that when creating API. And programmers have 2 main qualities, let's say. They are lazy and they have intuition. So they are lazy, so they want to do things as easy as possible without much effort, without much thinking. And they have intuition, so they have some kind of experience on or expectation based on experience on how things should look and what are the standards that things should conform to. And if API conforms to some standards and looks as expected, it's easier to work with in general. Okay, that was the Scout. So the principle of least astonishment is this beautiful shortcut at the bottom. Now we are moving to our wizards. The first wizard, Peter Morville. Anyone heard of? This is a guy from design, basically, and he wrote an article 10 or 12 years ago about 6 qualities of good product. So those qualities are basically product should be useful. It should have its purpose and fulfill that purpose. So if I need a product that is able to upload cut picture to the internet, it should do just that, upload the picture. The second thing, it should be usable. So it should be easy to do that. I shouldn't be able to think about different ways how to do that. For example, if I have API, I don't want to think about how to delete a car. If it's an endpoint called delete a car or remove a car or get rid of the car, I don't know. There should be just an endpoint about cars and HTTP method delete, and that's usable. Desirable, well, we all want products to be desirable, to be easy to work with, nice, and leave nice memories, let's say. Findable, that's basically about, in case of API, you don't want to look too long for API, so it shouldn't be buried under long URLs and lots of slashes, and you should not be forced to send emails to support to get documentation or stuff like that. Accessible, originally it was meant about products for people with some kind of disability. Say, if you are blind, it would be nice if you ride on elevator and you have braille characters on the buttons so that you know which floor to choose. In case of API, an example would be, say you have a proxy that only grants you GET requests and you want to do a POST or PUT, and how to do that. We'll get to that later. Credible, well, we would like our products not to break in the first place, but if our products break, we would like to be not left alone with that. So in case of API, if there's an error or something, it's nice to get a descriptive message, for example, or a link to FAQ, what to do with that. And in the original article, those values were composed into 6 hexes, and in the middle there was a hex value created from that. So that's the second wizard. First wizard, yeah. That's the second wizard. Roy Fielding, anyone familiar? No, okay. Roy Fielding was a guy who took a big part in designing HTTP and URI standards. And back in 18 years ago, I believe, he defended a PhD dissertation where he created the term REST. So if anyone asks you what is actually REST, the answer is it's not really a protocol, it's not a standard, it's not a technology. It's actually the architectural style of designing web architectures. So in this dissertation, he basically prepared, let's say, some framework to decide on which architecture is good, what are the properties, presented several architectures, and then came up with this REST idea. And the idea is based on 6 constraints, let's say. The first constraint, client-server, it was originally meant as backend and frontend, not really the case anymore. But the idea is that there are 2 separate parties that communicate, and you can develop both of them independently. They are not coupled. There is statelessness, which means that all the information that is required to process the request is contained in the request. So if you start some kind of business flow, let's say you reserve ticket and then you want to buy a ticket, you can reserve it on just one machine in the system, and then if the machine goes down or there is some scaling in the cloud or something else happen, the request can be handled under the covers by some other machine, and that's a nice property. On the other hand, sometimes we need to send more information to get it done, and how to deal with that with performance. So we have cacheability. So every response that we get from server contains some information on what terms and how long it can be cached, so that we use less performance of both server and the client. Uniform interfaces, it's basically about keeping consistency in URLs and using HTTP semantics, so methods, codes, and verbs. Verbs, codes, and something else, right. Code of demand is optional, actually, and it was about extending the functionality of a client via sending executable code from server. I did forget something. Yeah, layered system. That was about, you can introduce an additional layer between client and the server, and it shouldn't be really visible for the client. It should be transparent. So that was the second wizard. The third wizard, Leonard Richardson. Anyone heard of? What about Richardson maturity model? Okay, so that was something created at the KubeCon conference 10 years ago, more or less. And the idea is that the guy analyzed like 50 or 70 APIs, different APIs, and he coined the level of restfulness of those APIs. So how restful is the API? And the first level, level 0, the swamp of plain old XML. We have one endpoint, and we are sending a big XML to this endpoint telling what are we doing and on which resource. Not a very good idea. Then we have second level. We have separate endpoints for resources or entities in our system. Then we have HTTP verbs or methods. So now I don't have to think about this naming of the endpoint, whether this is delete car or remove car. I just have an endpoint cars particular ID, and I sent a delete method in HTTP. And the last level is this self-describing API, where you have, with response, you include some links that tells you what else there is interesting around that. And in theory, you can discover the whole API from one endpoint, also called HATEOAS, the beautiful acronym. Right, so that was basically the wizard, the theory. So now the practice. We talk about resources, naming, behavior of HTTP methods, relations between those resources, and how to operate efficiently on collections. So how to sort, paginate, and search in a collection. And at the end, how to deal with returning status or some inevitable errors in the API. Okay, so start. Resources. This is the focal point of REST, we can say. We have resources that are nouns, basically, in plural form. So we have a collection. For example, if you want to express a car, a collection of cars first, there's an endpoint cars. If you want a particular car, it will be cars/ID of this particular car. It's kind of important to remember about hiding the details. So if you have, say, Apache server or something, don't put the string Apache in the URL, just keep it clean and simple, because there's always some security risk in that. Naming. So the ancient war between camels and snakes, recently also joined by so-called hyphen case or kebab case, because like a kebab piece of meat on a stick, you have wars on this hyphen. So which is better? Basically, people from Java and JavaScript would tell you camel case is better because we have JSON as a typical response, and JSON is JavaScript, so camel case makes sense. It's kind of okay. On the other hand, people from snake case say, okay, snake case, you have this nice spacing between words, so it's more readable, and also you don't have to think about it's small letter or big letter, they are all small. There's a hyphen case, which has this problem that hyphen is also a minus sign. So if in case of some frameworks, automatic frameworks that somehow convert name of the properties or the objects to classes in programming languages, or name of the properties in a class, maybe there could be some problem. It looks nice if you have something that is consumable by humans. So for instance, if you create an article on WordPress blog composed of several words, as a link, it looks nice if this word is on a hyphen. But in general, in technical API, I would say it's better to go with snake case or camel case. Which one is better? Doesn't really matter, just keep consistent, unlike some standard libraries or some certain languages. So consistency is the key here. Relations between resources. There are two kinds of relations here in general. Either you have resources that can be independent, for instance, groups and people. People do not have to be in group, and in theory, group can become empty, but still have some information like founding date or something like that. So in that case, the mapping is basically something independent. So there is a resource group membership that can be deleted or added or altered somehow. On the other hand, if you have resources that cannot exist without other resources, let's say room in a building. If the building collapses, then the room is probably in trouble too. So in that case, we can go with this schema where we have the big resource, then /ID, and then the smaller resource beneath that. Behavior of HTTP methods. So what happens if you issue a particular method to either a collection or an object? So with get, to the collection. It's kind of simple. You just get the collection, of course. Maybe not entire collection, but it's good to limit that somehow, according to our ideas. Get on a single item is quite straightforward. You just get that item. Post. Post is kind of tricky. If you are issuing post to the collection, that means that you want to create an object in this collection, but you don't know the ID. So this is the object. Please put it under some name. You name it. If you use post on an object, a single object, that depends. Traditionally, it was partial update of this object, but it's not really used anymore because we have patch method. So it's better to use patch methods for that and maybe return just some error. With putting an entire collection, logic would dictate that we should replace this collection, but in practice, it's maybe not the best idea, so it's better probably to append to existing collection, and it's best to document it appropriately. And putting on an object is again tricky. If you just perform put on an existing object, that basically means that you are updating the entire object. If you are doing a put on non-existing object, then what should happen? You are creating a new object with the ID that you are supplying. And that can be a little bit tricky. It's okay, for example, in cloud system where you are just putting files in a cloud bucket and you name it as you like. But we should be careful with mapping those IDs to our internal system so that no external party dictates the IDs in our system, because it might be problematic. Or we can just use that functionality from our internal services. Delete. Yeah, delete on entire collection. Well, delete the collection. Of course, we need to be careful with that. Delete on single item is kind of straightforward again. And patch, this newer method, not that new anymore, but newer than the rest. Basically, on a collection, doesn't really make sense to patch a part of the collection because it's about single object. So on single object, you can replace just several fields of that if it's JSON or something. All right. Next, we have functions. So we said that that nouns are the focal point of REST and resources. So what if we have an endpoint that is a function actually? So basically, we can do two things with that. Either we can say that this is modification to some other resource. For instance, say you want to cancel a ticket for a train. So we have an object of booking, and you patch it and change status to cancelled instead of booked or something, or done. That's one thing. And another approach is just to create a new resource, because performing a function often results in creating a resource. So now we can think of resource called cancellation that is related to this booking, and that can have another additional information, for example, reason for cancelling or data or something like that. But in general, REST is not the only way of the architecture. So if you think you have a case to break the rules, just break them. Be sure to document that properly. Okay, as we are moving on to operations on collections, I briefly recap how we can parameterize requests. So basically, you can put something in an URL in a path. It's not really parameterization, because if you say cars/123, this 123 is actually the entire URL is the name of the resource. So it's not really a parameter. Parameters are rather part of the query after the, how this sign was called. Question mark, right? After the question mark, and they are optional and often used with collections. This is something we don't have to supply. If you want to distance ourselves from the business surface of the API, we can use headers, either standard headers or some custom headers. And sometimes we can just put something in a body. If for example, we can think of creating a search that has really a lot of parameters, we can just transmit this as a body instead of get method. And one note, if you have some parameter that is kind of meta or platform related or administrative, we can name it with an underscore as a prefix to mark that. Okay, so operational collections, searching, how to find something in the collection. If we are looking for a particular property, we can always use equals sign. So for instance, we are looking for people who are 27 years old. So we can say age equals 27, but what if we are looking for people that are either younger or older? We can use basically you can connect a name of the operator. So for example, LT for less than with some kind of separator and the value we are comparing against. That's one solution. Another solution is concatenate the name of the property with the operator. That's what Spring actually by default I think does. So if you are looking for a guy named Arnold, you can say name like equals Schwartz something there. Maybe we find him. Okay, so let's say we have objects that we are interested in and how to limit the content of the single object itself. We can specify a list of fields that we are interested in. Or from the other side, we can specify exclude the list of fields that we are not interested in. For instance, we have an object for a book and one field is very long and we don't want to transfer a lot of data. So we can go with that. There's also an idea to specify some styles of the objects like full, compact, some kind of medium, and we can use it as style or something like that parameter, a predefined value. Okay, we've searched. Now let's sort that. The easiest way to do this is just name one property that we are sorting against with some default order. If we want to sort by more properties and with different order, we can just list them and add prefix or suffix to that to specify the sort order. Or we can list the properties and then list which are ascending and which are descending. Next method is just to mirror for each property that we are sorting against. We are specifying the direction, and I think actually this is pretty the same as the second one, but just with the prefix. We can just specify the name of the property with a single plus or minus as a prefix or suffix, whatever. That's kind of elegant style. I think I like it the most of them. Okay, now going on to pagination. So classically, we are using some kind of either index or page number and then limit or size of the page or whatever, but then we run into the problem that if somebody is concurrently modifying the collections while we are iterating with these windows, we might get some object twice or not at all. So how to help with that? We can have cursor. So we defined like the pointer to an element in the collection, and then we have a page size from counted from this cursor. And this should prevent us from getting an item twice at least. Something between pagination and, let's say, searching is an idea to create a semantic name of the page. So for instance, if you have a ticketing system and you want to have recently closed items, you can say that, okay, I'm looking for an item with specific status and modification date or something, and just name it recently closed as a convenient method for developer. We can also specify the parameters of collections in a header, accept range header. And it's a good idea to always provide some links to next page, previous page, maybe first one and last one. That's about more or less collections. So now status. Also with the status, there are a lot of statuses in HTTP. I think in 1.1 we have around 75 or 80. So how many statuses should I use in my API actually? There are some vendors that only use one status, for example Facebook. They just always return to 100, and whatever else happens is part of a description in an object or a field. But it's not exactly the best idea. For example, just the convenience of using requests from Postman or other tool, you can see this either green or red or yellow dot to immediately see the class of the statuses. You see what happens. If it's red, it's probably some kind of error and it alerts you. So I think the usual range is somewhere between 1 and 20, with probably 10 or 15 being quite okay. Aside from HTTP status, what if there is an error? So it's a good idea to return an object that would say what really happened. So what this object should contain, first thing is some kind of enumeration. So one of the possible error situations. It can be meaningful in name, for example, booking _ fraud or something like that. Or there's an idea to extend HTTP status with additional digits. So for example, return a 5-digit code that corresponds to HTTP status you use. Second thing is a descriptive message what happened. And it could be localized, because you would think that English is the standard language of messages in APIs. Not really. In many countries like Austria or Switzerland, they say, German is the default language, and I will return my errors in German. And you can have developers in some distant country that, for example, don't speak very well in English or just don't like it, and maybe they would want to have messages in their own language. So that's a convenience feature we can include. The third thing we can add is like more details, but not exactly in the response, but as a link to FAQ, for example, or some kind of documentation section particular that would help the developer understand what really happened. And again, be careful about exposing details. I saw some APIs that return stack trace in response as a header sometimes, and it might be a security problem, unless you are open source maybe. But in general, be careful with that. So briefly on codes. 200, everything is okay. 201 we return when we create a new object. 202 is used in asynchronous processing. So to say that, okay, I got the request, I'm on it, but the result is not yet available. It will be somewhere, somehow. No content when we delete an object, and partial content when the responses have more parts. And then we have additional headers with the range. 300 is kind of tricky, the whole group, but especially the status 300, because there is no clear consensus on how to handle that. So it's not really very often used. On the other hand, 301 move permanently. That means the URL is obsolete, and you should not call it again. Just use the new URL that is provided in the location header. 302 is deprecated because it was initially meant as 307, but in early browser it was implemented as 303. And what those means? 307 basically means that first the redirect is temporary, and you should again use the same method in the new place. So if I use post on this on the endpoint and I get 307, then I should go to another endpoint and again use post because nothing happened. On the other hand, see other means go to different endpoint and use get to retrieve results. So I am issuing post, and now something happened, and the result is ready with get on another endpoint. That's with the redirection. 400, I guess most error falls into this category. Unauthorized in HTTP really means unauthenticated, so I don't know who you are. On the other hand, forbidden means actually unauthorized, so I know who you are, but you can't do this. There is this naming mismatch with that one. You should be aware of. 404, we all know that. 405 is a way of saying that the object exists, but we can't perform a particular method on it because it's immutable or something else. If it's related to security, because we can't do that, we should rather use 403. Conflict, 409. This basically means that the request is in a conflicted state with what is on the server. So, for instance, you want to delete a bucket that still has files in it. Excuse me. Gone is a way to say that there was an object under this link, but it's not anymore. And unprocessable entity. Damn it. Winter is coming. Unprocessable entity is about kind of an error, but on a higher level of abstraction. So if you have malformed JSON, then you would return 400. But if you have, say, arrival date, before the departure date, that's a business problem, and that's a good candidate for that error. Okay, the next group, last group, 500, internal server errors. 501, it's a polite way of saying that something is under construction. So maybe it will be there in 2 weeks or something. Come back, check again. But gateway and gateway timeout are kind of similar in a way that this is saying that when acting as a gateway, we got an error, and it's okay if you have internal APIs, but in external API, I don't really care about what happened in internal services. I just want to get a result and proper code. So it's not really advised in external APIs. And service unavailable. That's basically a way of saying that we have maintenance and everything will be okay, come back later. Right. So that's the main business part. I want to do support. So we will briefly look at security, versioning, caching, throttling, a bit of HATEOAS and some miscellanea. If you don't know how to name a thing, you can just put it under miscellanea category. So security, that's of course a topic that is kind of broad and a good topic for entire presentation. But in general, it's 2018, we should use HTTPS everywhere wherever possible. If someone is attacking our endpoint without HTTPS, do not redirect, just return an error. Don't invent your own ciphers and cryptography, even if you have PhD in that and 10 years of experience. It's probably not the best idea. And API keys instead of username. So basically keys have better density for information, entropy, and are inherently more secure than username and password. And there is this OWASP project. There's a site where you have top 10 threads in web application. It's always good to check it every year or so as they are changing. Okay, quickly versioning. So our API is changing. We have to reflect that somehow. And there are several ways to do that. First, we can just put version in an URL. It's by far the most common, I think, scheme. But it's not very restful, in fact, because now what happens is that one resource can be available under many links. On the other hand, we can use parameter for that, and then if somebody doesn't provide this parameter, we can either do the latest version, or maybe use the version that was used by the client when he registered, if we are registering clients. Again, if you want to distance ourselves from the business surface of the API, we can use headers, either accept header or some kind of custom headers like GitHub or Microsoft does. Or we can just drop versioning at all. There's the website, the dating website Badoo, that does that. And basically what they do is just the client is negotiating the features, for example, the list of fields in an object that the client expects. And then if an older version of the API has, say, a boolean true false, but the newer version has a enum with 3 values, then the client just says which version he wants and he gets it. And we need to also remember that the version of the API and the version of the object are 2 different things. So we can have the same object accessible through different versions of API, and also different versions of the object access from the same version of the API. Okay. Cache control. One of the pillars of REST. So we have this cache control directive. And it can have a lot of values. Actually, it's more like 20 or 30, I think, even. But the most important are those public and private. So whether the request or response is meant for a single client, it should be marked as private. If it's something that is common, like a logo of the web page, it's okay to be public. If the data doesn't have to be fresh all the time, it can be a little bit stale, then we can put max age and specify how stale it can actually be. If you use no cache, it doesn't really mean that we are not getting any benefits from caching. It just means that every time when the resource is checked in cache, it has to be validated against the server if it's still okay. And if not, the new version has to be downloaded, and only then it can be returned to actual client. So we have some performance, but also the resource is always okay. On the other hand, no store basically means that we can't use caching at all, and this is actually suitable for sensitive information like medical stuff or banking stuff or things like that. So basically, how to design a good caching strategy, we have to look at our data and particular endpoints and think whether this is meant for a single user or just publicly available, if it's sensitive information or not, and how much off time it can be. And then we can have some sensible strategy. Throttling. This is the idea that we can handle only so many requests. So what to do when we are out of capacity? We can just return 500. Now it's not very elegant. We can use those particular headers to say how many requests we can fulfill in a particular time window, how many requests are left in this current time window, and when the new window starts. And then if client is out of luck and no more requests can be processed, then we can just return 429 too many requests. And then the client knows that it can check those headers and, for example, see that in 70 seconds, new window opens and I can try again. I don't have to repeat every second or so. Okay, HiToes. Who of you played Diablo 2? Yeah, there are some people. So we have Lord of Mephisto, Lord of Hate here, Lord Mephisto on the picture. I thought it will go well with the slide. So the idea of HiToes, I keep forgetting the hypermedia as the engine of application state. Yes. So the idea is that we have this self-describing API where we include links to other related resources and operations that we can follow. And there's no really one good standard on how to do this. There are several. There is whole, that is probably the most popular. There is collections plus JSON that was initially meant as for collections, but works well with links. There is JSON LD, which is basically easy to introduce without breaking backward compatibility. And there is Siren, that is probably the most powerful, but not very prominent, not very popular, let's say. And there are also some drawback to HiToes because not many clients actually use that, and there is an overhead in performance. So there is actually a discussion whether to use it or not. Okay, going to the soft side, documentation. So we have, let's say, 3 tiers of documentation. First, you have an exhaustive phone book where everything is exactly documented and our options are enumerated, and it's incredibly boring. On the other hand, we have this engaging tutorial where we have some kind of business story and a flow, maybe some examples with requests and purpose of them. And there's a quick start where the developer can just paste something and start with that. We have the typical standard Swagger and RAML. If you want to prototype something fast, you can use RAML. In other cases, maybe Swagger. And always the good idea is to have some kind of interactive examples. So, for example, Swagger can generate the example requests, and you can just click, try it, click, and it works. It's always useful. Okay. Coming to an end, miscellanea. So what I mentioned about disabilities, if we have a proxy that only allows GET requests, we have this XHTTP method override header, and we can specify the actual method that we want to call. We can provide an option, maybe it's not very relevant with modern browsers, but there's an option to prettify the JSON response. So we can add some pretty parameter, and then it says add new lines and spacing to the response. Sometimes useful. On the other hand, if you want to encode to zip the response, there is a standard header for that compression for content encoding. Resource UID. So when we are creating new resources, maybe instead of naming them like 1, 2, 3, etc., we can think of some unique random IDs that are like 64 or 128 bits long, so that it's more difficult to guess just the resource and get basically all your data. Request UID. The idea, also called correlation ID, when you start a flow in, for example, microservice system, you can add a header or something with request UID or correlation ID, and then if several services are using that, it might be easier to follow the flow in logs of such system. More miscellanea. Some API vendors have this idea that if you are using a browser, then HTML should be returned instead of JSON. It's basically a bad idea because we have content negotiation for that. I have some standards, so let's not invent new ones. Application, have an application info endpoint. The idea is that besides stuff for our automation or Kubernetes or something, besides having stuff for automation to know whether the service is healthy or not, we can add some additional information in internal APIs. For example, a git commit from which the service was built, or value of important properties that are currently used. That might be helpful in some debugging or investigation. And last but not least, the creating of external API in normally B2C system is kind of tricky, because at first you would think that that's just adding an additional application gateway or something, a bit of security, stuff like that. But in practice, it turns out that those systems are often not really crafted for working business to business. And for example, you don't have invoice flow or stuff like that. And on the other hand, you have to now add, in many places, one additional small field like partner ID or something. And those projects often turn, let's say the proceeding of those projects are often that we are doing many changes, many small changes in many repositories. And this might be a problem for some people, but on the other hand, you have an opportunity to get to know your system better. And to sum up, API has a lot of aspects. Sometimes we don't think about some of them, but depending on our resources and priorities, there are a lot of things that we can do to make developers' life easier. API is to the developer as graphical user interface is to regular user. So basically, we can think about this as a product. Let's remember that in case of REST, the resources and nulls are the focal point of the architecture. And we have semantics of HTTP, so methods, headers, and response codes. So it's a good idea to follow those principles, but maybe not religiously and blindly. If something doesn't fit your architecture, just bend the rules or break them. Just be sure you know what you are doing. Okay, if you fall asleep or just came later to this lecture, most of what I said and a bit more is written in currently, I think, 9 articles on my blog. It's called How to Train Your Java, just like the movie How to Train Your Dragon, but with Java instead. So you are welcome to drop by. And about questions, I know that's the last lecture and I wouldn't like to keep you too long. So if you have some questions, just come to me and we can talk, or you can reach me later. And for now, thank you.